Hello everyone, I am Meghna, currently pursuing BE degree in Sri Venkateshwara College of Engineering. In this video, we're going to learn about the topic data processing instruction from a subject microcontroller and embedded system, which bears a course code of 21 CS 43. Moving further, these are the contents we'll go through it. Before getting into the topic, at first we need to know what is meant by data processing in embedded system. It's a collection, manipulation and processing. Collected data for a required use is known as data processing. It's a technique normally performed by a computer. The process includes retrieving, transforming and classification of informations. The four main stages of data processing cycle are data collection, data input, data processing, data output. And next we'll move on to the topic data processing instruction. The data processing instruction manipulate data within registers. There are move instruction, arithmetic instructions, logical instruction, comparison instructions and multiply instruction. Most data processing instruction can process one of their operands using a barrel shifter. If you use this S suffix on data processing instruction, then it updates the flag in the CPSR, which means current program status register. Move and logical operations update the carry flag C, negative flag N, and zero flag Z. The carry flag is set from the result of the barrel shifter has the last bit shifted out. N flag is set to the bit of 31 and Z flag set the result is 0. And next we'll learn about the types of data processing instruction. The first one is move instruction. The move is an output instruction in a ladder logics, moves the source value to the destination location. As long as the rung remains true, the instruction moves the data each scan. Like the syntax used for move instructions are, and it carries instruction, condition, and S has a condition flag, RD as a destination register, N as a source register. Where the move instruction copies the N into a destination register RD, where N is the register or a immediate value. Next, we'll have a simple example for move instruction. Here, R5 carries a value of 5 and R7 as 8 before the execution, where move instruction copies the value of R5 to the R7, where after the execution, we'll get a value of R5 and R7 register as a 5. And the second example is arithmetic instruction. The arithmetic instruction defines the set of operations performed by the processor, that is ALU. The arithmetic instructions are further classified into binary, decimal, logical, shift or rotate, and bit or byte manipulation instructions. The binary arithmetic instructions perform basic binary integer computations on byte, word, and double word integers located in the memory. This is the syntax for an arithmetic instruction where it contains an instruction, condition, then a condition flag, destination register, and RN are the source register. These are the instructions used for adding of 32-bit values or reverse subtract or subtracting two 32-bit values, where ADC is used to add 32-bit values and a carry, where ADD is used to add two 32-bit values. SUB is used to subtract two 32-bit values, that is RD, where it is stored in a destination register with when Rn and N are the source registers which carries an value. And next we'll have a simple subtract instruction subtracts a value stored in a register R2 from a value stored in a register R1, and the result is stored in R0. And next we'll have another type, that is logical instruction. The processor instruction set provides the instruction and or XOR test and not Boolean logic, which tests, sets and clears the bits according to the need of the program. The syntax used for logical instructions are which contains instruction, condition, a condition flag, RD as a destination register, RN, N as a source register. These are the logical instruction values and is used for logical bitwise and of two 32-bit values, and O or R logical bitwise OR operation where EOR performs a logical exclusive OR operation. And next we'll have an example for logical instruction, where this example shows a simple logical OR operation between register R1 and R2 where R not holds the results. And next we'll have another type, comparison instruction. The data comparison instruction gets the PLC to compare two data values. Thus, it might be to compare a digital value read from some input device with a second value contained in a register. The syntax for comparison instructions are instruction, condition, Rn, and N, where N is the result of the shift operator. These are the instruction used for comparison instruction, where CMN compare the two registers, CMP performs compare operation, TEQ performs test for equality of two 32-bit values. And now we'll have an example for comparison instruction. And this example shows a CMP comparison instruction to, to compare, and you can see that both register R0 and R9 are equal before executing the instruction. The value Z flag prior to the execution is 0 and it is represented by a lowercase letter Z. After the execution, Z flag changes to 1, that is, and to uppercase letter Z. This indicates the equality. And next, we'll have a multiply instruction. The multiply that contains of a pair of registers and depending upon the instruction, accumulate the results and with another register. The long multiplies accumulate onto a pair of registers representing a 64-bit value. The syntax used for multiply instructions are MLA, which stands for multiply and accumulate, and MUL stands for multiply. Later, let's have an example for multiply instruction. This is a simple multiplication operation performed where before the execution R0 value is 0, where R1 and R2 registers contains a value of 2, where MUL instruction is used after the execution R0 contains a value of 4, where a simple multiplication is used in between a register R1 and R2. That's all about the data processing instruction. I hope that the video was informative. Thank you for watching the video.